Stay home, save lives.
Hello students, coming to physical properties of amines. As usual, as we have discussed the two physical properties, that is solubility and boiling point for other organic compounds, amines also we will discuss solubility and boiling point. Coming to solubility, amines, whether it is a primary, secondary or a tertiary amine, have nitrogen atom in it, and the electronegativity of this nitrogen atom is more than hydrogen as well as the carbon with which it is bonded. Therefore, in amines, nitrogen atom acquires a partial negative charge. You can see here a partial negative charge. Due to this negative charge on the nitrogen in amines, amines form intermolecular hydrogen bond with water. Therefore, this is also soluble in water. That means amines are soluble in water. But if we compare the solubility of amines with that of alcohols, so alcohols we know have OH bond in them. Alcohols have OH bond, OH as the functional group in them. And the electronegativity of oxygen is more than the electronegativity of nitrogen in amines. That is why in alcohols, the OH bond is polar, more polar as compared to the NH bond in amines, and alcohols are more polar than amines. Therefore, alcohols forms more stronger intermolecular hydrogen bond with water. Therefore, amines are soluble in water but less soluble as compared to comparable molecular mass alcohols. This was a comparison between the solubility of amines and alcohols of comparable molecular masses. Now, if in a particular type of amine, whether primary, secondary or tertiary, if in a particular type of amine, as the molecular mass of amine goes on increasing, that means the size of this alkyl group goes on increasing, the solubility of amines in water goes on decreasing. What is the reason for this fact? As the molecular mass, that means the size of alkyl group in a particular type of amine goes on increasing, its solubility in water goes on decreasing. The reason behind this fact is that the alkyl groups are hydrophobic in nature. That this means that as the size of alkyl group goes on increasing, hydrophobic part goes on increasing and it goes on becoming dominant, and therefore because it is hydrophobic in nature, it will go on decreasing the solubility of amines. That is why lower aliphatic amines are soluble in water, but as the molecular mass of amine will go on increasing, its solubility in water will go on decreasing. This was about solubility of amines and its comparison with the solubility of alcohols. Coming to the next physical property of amines, that is boiling point. Repeatedly, we have seen that boiling point or melting point is that property that depends on the strength of intermolecular forces of attraction. Now, as we can see here, that primary amines have 2 NH bond. You can see here, this is the structure of primary amine having 2 NH bonds. Secondary amine have 1 NH bond. Now, the polarity of this NH bond. This NH bond is a polar bond. The polarity of this NH bond in amines makes the amines molecules hold together by intermolecular hydrogen bond between themselves. As in the property of solubility, we have seen that amines are capable of forming intermolecular hydrogen bond with water, but their molecules themselves are also held together by intermolecular hydrogen bond due to the presence of this polar NH bond, and therefore their boiling point is more as compared to comparable molecular masses hydrocarbons, that is alkanes, even more than ethers. This is due to the presence of intermolecular hydrogen bond between the molecules of themselves. Now, if we have to compare the boiling point of primary, secondary and tertiary amines among themselves, then we can see that in primary amines there are two NH bonds. Now, if there are two NH bonds, their molecules will be held together by more degree of association through intermolecular hydrogen bond, because these both the NH bonds will be capable of forming intermolecular hydrogen bond. So, the boiling point of primary amines will be maximum among these three types. Then secondary amines have one NH bond, so their molecules will be held together also by intermolecular hydrogen bond, but the degree of association will be comparatively less. And in tertiary amines, we can see there is no NH bond. Here the nitrogen atom is binded with all the three alkyl groups. There is no NH bond. So here there is absence of intermolecular hydrogen bond between its molecules. So what will be the order of boiling point of primary, secondary and tertiary amines? Obviously, primary amines boiling point will be maximum because in them there are two NH bonds. So degree of association between their molecules through intermolecular hydrogen bond is more. Then boiling point of secondary amine, and then least will be the boiling point of tertiary amines. This is the order of boiling points of various amines. Here we have not taken aryl amines, that we will talk later. Here we are only comparing the boiling point of primary, secondary and tertiary alkyl amines. So these were two physical properties of amines: solubility and boiling points. Now coming to chemical properties of amines. Chemical properties of amines. The very first chemical property of amine to be discussed is its basic nature. What are we talking about? Basic nature of amines. What do we mean by basic nature? That amines are basic in nature. What type of bases these are? Let's talk about that. We know in amines there is a nitrogen atom. Nitrogen atom have a lone pair of electron, and therefore amines, due to this presence of lone pair on the nitrogen atom, is capable for donating this electron pair. So they will behave as Lewis base. Other than this, these amines, again due to presence of lone pair on nitrogen atom, have also the capability to accept a proton. Therefore, they will also behave as Bronsted bases as well. Lewis as well as Bronsted bases. Now, if these amines are basic in nature and we want to write the chemical equation showing the basic nature of amines, we can write this reaction in the form of its reaction with any acid, where base means this amine is accepting a proton from that acid. Let's look at one of such reactions. Here I am taking any aliphatic amine like NRNH2. When this aliphatic amine, as we told, is basic in nature have a lone pair or nitrogen atom have a tendency to donate this lone pair to any electron deficient species and also have a tendency to accept a proton. Let's see its reaction with, suppose we are taking water. Now, in this reaction, here you can see I am putting a reversible sign here. In this reaction, amines, because are behaving as a base, will accept a proton from this water and they will convert into our NH3 with a positive charge on nitrogen. This is substituted ammonium ion. Along with this, OH minus from this water will be formed. So this is a reaction in the form of equation showing the basic nature of amine. As in this reaction we can see amine is accepting a proton. Now if we find out the equilibrium constant of this reaction, which will be denoted by Kb, base dissociation, because this is the reaction showing the basic nature of amine. So the equilibrium constant of this reaction can be denoted by Kb, that is base dissociation constant. How will I write the formula for this Kb? Concentration of products. What are the products here? Are NH3 positive, concentration of OH minus ion upon concentration of reactants, that is concentration of amine, concentration of water. Why I have written the formula for Kb? Because if we want to express the basic strength of any base, we have till now talked here that amines are basic in nature, Lewis base as well as Bronsted base. But the basic strength of any base is expressed by a term Kb. How is the value of Kb related to the basic strength? It is directly proportional. Kb is directly proportional to basic strength. That means more is the value of Kb for any amine or any base, more will be its basic strength. We will also see the comparison between the basic strength of primary, secondary and tertiary alkyl amines and ammonia. But here we are looking that the basic strength can be expressed by a term Kb. And how is it related to basic strength? Directly proportional. Another way to express the basic strength of any base is pKb. What is pKb? Like pH. What is pH? pH is the negative log of hydrogen ion concentration. Same way, pKb is the negative log of Kb. And this pKb is also a way to express the basic strength of any base. But how is the relation between pKb and basic strength? It is inversely proportional. pKb is inversely proportional to basic strength. So these are the two ways to express the basic strength, Kb and pKb. Right now we have seen that amines are basic in nature due to the presence of lone pair of electrons or nitrogen. Therefore, they will act as Lewis base, as well as because they have a tendency to accept a proton, they can also behave as Bronsted base. And their basic strength of amines here also we can express with the help of Kb and pKb values. So this was just that they are basic in nature. Now we have to compare the basic strength of alkyl amines and ammonia among themselves. Therefore, here we have a comparison between the basic strength of primary amine, secondary amine, tertiary amine and ammonia. Let's understand this comparison. We know that primary amines are RNH2. These are primary amines. And you can see here there is only one alkyl group attached with nitrogen atom in primary amine. In secondary amine, the formula is R2NH. Here you can see there are two alkyl groups attached to nitrogen atom of amine. And in tertiary amine, it's R3N, where three alkyl groups are attached with nitrogen atom. This is primary amine, secondary amine and tertiary amine. Along with these three types of amines, I am also drawing the structure of ammonia here. What is ammonia? It is NH3. That is, in ammonia, there is no alkyl group attached with nitrogen. Now, what happens due to the presence of alkyl groups in various types of amines? We know that alkyl groups show plus I effect, that is electron releasing effect. What is electron releasing effect? They have a tendency to release, that means to move the sigma bond electrons away from themselves and towards the atom which is bonded with them. Alkyl groups shows plus I effect. And how do we show plus I effect? With the help of arrow. Let's show that plus I effect in all the three types of amines. Here in primary amine, there is only one plus I effect due to one alkyl group. In secondary amines, there are two alkyl groups, so both will show plus I effect. In tertiary amines, there are three alkyl groups, all the three will show plus I effect and release the electron towards nitrogen, that means away from themselves. Now this is the plus I effect shown by all the three types of amines. Whereas in ammonia, there is no alkyl group, so no such plus I effect. Now what is the effect of this plus I, that means electron releasing effect? Let's see. Now because of due to this plus I effect of alkyl groups, the electrons of sigma bonds are shifted towards nitrogen atom. That is why the availability of electron density on this nitrogen atom will increase and its tendency to donate the electron pair will also increase. What the point is that due to plus I effect of alkyl groups, the availability of electron density on nitrogen will increase. Therefore, its tendency to donate the electron pair, that means basic strength, will also increase. That means more is the number of alkyl groups attached to nitrogen atom, more will be the plus I effect, more will be the electron density on nitrogen atom, more will be its ability to donate the electron pair, and more basic it will be. Now that means out of primary, secondary, tertiary amines and ammonia, tertiary amines will be most basic because they are having three alkyl groups in them. Then secondary amine, then next in decreasing order will come primary amine, and the least basic will be ammonia. So what will be the order of basic strength of various types of alkyl amines and ammonia will be, I am writing that order. Right now I am writing the order in decreasing order. The most basic will be tertiary amine, then will come secondary amine, then will come primary amine, and then will come ammonia. This is the decreasing order of basic strength of alkyl amines and ammonia in gaseous state. Note the point, this is the order of basic strength in gaseous phase. That means when amines are in gaseous phase. That means we are talking in gaseous state of amines. But when the amines are present in aqueous form, in aqueous solution form, that means dissolved in water, then the factors that govern the basic strength of amines is not only the inductive effect of alkyl group, but some more factors are there. So you have to remember, first of all, the basic strength of amines in gaseous state. Gaseous state is that state in which usually they occur. So if in exam the question is asked for their basic strength without mentioning the condition, you have to consider their normal condition, that is in gaseous state, and this is the order. But if it is asked in aqueous state, then as I told you, the factors which govern the basic strength are three factors which we will discuss now. Now we have to discuss the basic strength of amines in aqueous medium. In aqueous medium, the basic strength of amines is determined by three factors. First factor is plus I effect of alkyl group. Plus I effect of alkyl group here also works in the same way as it works in gaseous phase. That means according to plus I, that is electron releasing effect of alkyl groups, the order of basic strength of amines should be 3 degree, that is tertiary amines more than secondary amines and more than primary amines. Reason for this we have explained while discussing the basic strength in gaseous medium. So here also the first factor is same. What is the second factor which decides the basic strength of amines in aqueous medium? That is the solvation effect. Now here, because we are talking in aqueous medium, we can use a better word, hydration effect. Hydration effect when the solvent is water, otherwise in general solvation effect. What happens when amines behave as a base? They accept a proton, and when they accept a proton, they are converted into their corresponding cations. Let's see which type of cations they are converted. Here this is primary amine RNH2 accepting a proton and converting into RNH3 cation, nitrogen with a positive charge. This type of cation is formed by primary amine. When it is a secondary amine R2NH, it will accept a proton and convert into R2NH2N with a positive charge. Similarly, for tertiary amine R3N, it will accept a proton, convert into R3NH cation. So these are the three cations formed by primary amine, secondary amine and tertiary amine after accepting a proton. Now when this basic nature is taking place in aqueous medium, these cations which are formed are hydrated. That means surrounded by water molecules, and this hydration takes place through hydrogen bonding. How this hydration takes place? Let's see. This is RNH3 is the cation formed by primary amine. Here there are 3 hydrogen atoms. All these 3 hydrogen atoms will be hydrated through hydrogen bond with H2O, water molecules. Similarly, the cation of secondary amine R2NH2 has 2 hydrogen atoms. So they will be hydrated through 2 hydrogen atoms. And in tertiary amines, cation of tertiary amines R3NH, since there is only 1 hydrogen atom, it will be hydrated by only 1 hydrogen bond. That means the extent of hydration is maximum for the cation of primary amine, followed by the cation of secondary amine, then coming to the cation of tertiary amine. More is the solvation, that means hydration, more stable is the ion. That means cation of primary amine is more stable than secondary amine. Secondary amine is more stable than tertiary amine. More stable is the cation, more basic will be the amine. That means more will be the nature of that amine to accept a proton and convert into the stable cation. That means according to solvation effect, since the extent of hydration is maximum in primary amine cation, followed by secondary amine, followed by tertiary amine, the basic strength, the order of basic strength for these types of amines will be, according to solvation effects, the order of basic strength will be primary amines more stable, not more stable, more basic than secondary amine, and secondary amine more basic than tertiary amine. So the second factor, which is deciding the basic strength, is just reverse of according to plus I effect of alkyl group. That is primary more basic than secondary, more basic than tertiary. Now let's have a look on third factor which decides the basic strength of amines in aqueous solution. Let's look at that third factor. That third factor is steric hindrance. What is this steric hindrance? What do we mean by this steric hindrance? Let's see. We are talking about steric hindrance. Steric hindrance means the resistance, the barrier which is caused in hydrogen bond formation with water molecules, and this steric hindrance is caused by the size of alkyl group. As we have seen in solvation effect, that when amines are converted into their cation by the acceptance of proton, for example, here I am writing for primary amine cation, this cation of amines are further hydrated through hydrogen bond. These are hydrated. More is the hydration of cation, more stable is the cation, more stable is the cation, more basic is that amine. This we have just now discussed in solvation effect. But if the size of this alkyl group R in amines is such that it is creating a steric hindrance, that means it is creating in space the resistance for the formation of hydrogen bond with water. That means it is stopping that cation to form hydrogen bond with water. Then, although being the primary amine cation and 3 hydrogen atoms, if the size of alkyl group is such that it is creating a steric hindrance, no such hydration of cation will take place, and the role of solvation effect will not work for deciding the basic strength of amines. But whether this solvation effect will work or not, that depends on the size of alkyl group. So we can say overall there are 3 factors that decides the basic strength of amines in aqueous solution: plus I effect of alkyl group, solvation effect of the cations of amines, and third is steric hindrance due to the size of alkyl groups. Now, when all these 3 factors work, what will be the result? The combination of all these 3 factors will decide the correct order of basic strength of amines. The combination of these 3 factors will decide. And we have to see the combination of all these 3 factors for methylamines as well as ethyl amines. Methylamines and ethyl amines. Let's look at this combination. So, first we will look the combination of these 3 factors for deciding the correct order of basic strength of methyl amines. for methylamines, the correct order of their basic strength is first, the highest basic is secondary amine. As you can see here, CH3 twice NH I have written. Secondary methylamine is most basic, followed by primary methylamine, that is CH3NH2. And the primary methylamine is more basic than tertiary methylamine, that is CH3 thrice N, and last will be the ammonia. So this is the correct order of basic strength of methylamines, and this order is the result of combination of all those three factors. We can't individually apply all the factors, but the combination is giving us this result for methylamines. In case of ethylamines, let's look the result. In case of ethylamines, the very basic ethylamine is same, that is secondary, as it was for methylamine. Secondary ethylamines are most basic, but now the order will change. For ethylamines, now the turn comes of tertiary amine. Secondary amines are more basic than tertiary ethylamine. Tertiary are more basic than primary ethylamine, that is CH3, CH2, NH2, and last here also will be ammonia. That means in aqueous solution, the basic strength, the order of basic strength of methylamine and ethylamine is this, which you have to keep in mind, learn it, revise it, and remember it. And how is this order coming? That is due to the combination of all the three factors: plus I effect of alkyl group, solvation effect, and the size of alkyl group, that is steric hindrance caused by alkyl group. This is order in aqueous solution, and in gaseous state the order is always same, that is tertiary amines more basic than secondary, secondary more than primary, primary more than ammonia. This is the order in gaseous phase, which is same for all type of amines, but in aqueous state this is the order for methylamine and ethylamine.